Let's see how you did here. So on the first one, we first have to figure out which sides correspond to each other. So what side in the other figure corresponds to the 12? The 8, because of the way the angles are marked. They're not drawn the greatest, but the angles are marked. What would correspond to the Z? The 10, okay. How about the Y? The 2, and finally the 5x. So what ratio am I going to start with? 12 over 8. Or 8 over 12, it doesn't matter, whichever way I want to set it up. I could reduce that to 3 over 2 or 2 over 3 if I wanted to. I'm going to leave it like that for now. If I want to find x, where's x going to go, top or bottom? Bottom, because it's from the same figure as the 8. What goes above it? The 5. We cross multiply and divide, we get 3 and 1/3 equals x. Keep going for y. Where's y going to go? On top, what goes below the y? 2. We cross multiply and divide. Y equals 3. If we keep going, 12 over 8. How about with the z? Where's the z go? Top. What goes below it? The 10. And we cross multiply and divide, and z equals 15. So now for this one, it's three-dimensional, but it doesn't matter. I'm still just comparing lengths. X, of course, corresponds to 8. 20 corresponds to y. And 12 corresponds to 3. So I've got the 12 over 3. If I want to find x, where does x go? On top. And what goes below it? 8. So we cross multiply and divide here. 12 times 8 divided by 3 is 32. And then we do the same for y. Y is on bottom. What goes above the y? 20. So we cross multiply and divide. We get that y equals 5. Any questions on those? Okay, so today's task is to look at things like this. Still similar figures, but we're going to look at areas and volumes of similar figures. So let's start out with a rectangle that looks like this. We got a 2 by 5 rectangle. I'm going to enlarge it to be 6 inches by 15 inches. What is my ratio of lengths here? Well, 2 becomes what? 6. So my ratio of lengths is 2 to 6. Or if I reduce it, 1 to 3, right? What's the area of this rectangle? 2 times 5 is 10 inches squared. What's the area of this rectangle? 6 times 15 is 90 inches squared. Square inches. My ratio of areas is 10 to 90, or 1 to 9. Now we're going to keep an eye on that. And we're going to look at circles. This circle has a diameter of 2 inches. This circle has a diameter of 8 inches. What's my ratio of lengths there? 2 to 8, which will reduce to a 1 to 4, right? What's the area of this one? Pi times what? 1 squared, so just pi. So 3.14 inches squared. How about this one? Pi times 4 squared, or pi times 16, which is 50.24 inches squared. 26. If you use the pi key. I just use 3.14. The ratio of areas here is 3.14 to 50.24. If I divide both of those by pi, that's a 1 to 16 ratio. Now, looking at the relationship between those ratios, here I have a ratio of lengths of 1 to 3, gives me a ratio of areas of 1 to 9. Here I have a ratio of lengths to 1 to 4, gives me a ratio of areas of 1 to 16. Do you see a relationship there? Not just the bottom number, but the whole ratio, right? 1/3 squared, what's 1 squared? 1, what's 3 squared? 9, that's 1/9. 1/4 squared, what's 1 squared? 1/4 squared, 16. Now in both of those, the numerator was a 1 in my ratio of lengths, but I can do one like this. So this is 4 inches, and we're going to do 10-inch square. My ratio of lengths is 4 to 10, which reduces to 2 to 5. The area here, 4 by 4 is 16 inches squared. The area here, 10 by 10, is 100 inches squared. So the ratio of area, 16 over 100, or if I divide by 4, that's 4 over 25. Again, if I take 2/5 and I square it, 2 squared is 4, 5 squared is 25. So I get the same ratio. Now in simple figures like this knowledge isn't horribly useful. Where it becomes useful is if we have some complex shapes like this. So let's say we have this shape, we had to enlarge it, and originally this dimension here was 8 inches, and it had an area of 120 inches squared. But here we had to enlarge it so that this dimension is now 12 inches to find its new area. Since it's not going to be so easy to calculate the area of that shape, we compare it back to something we know is similar to it. So our ratio of lengths is what? 8 to 12, and I'm going to reduce that to 2 to 3. So that means my ratio of areas must be 2/3 squared, 2 squared is 4. 3 squared is 9. So 4 to 9. So then I'm going to plug in the 120 goes with what? The top or bottom? It's from the smaller figure, so it has to go with the smaller number. So it goes on top. So 9 times 120 divided by 4 is 270. So it's 270 square inches. So find the missing area. If this dimension here goes from being 6 inches to 15 inches, and the area of this shape was 62.5 square inches. Find the area of this shape. I'll give you a minute to do that in your notes. Then we'll take a look at it. Ratio of lengths. 6 to 15, which reduces to 2 to 5. Good. So to get my ratio of areas, I do my 2 to 5, and I do what to it? Squared. Gives us 4 to 25. Where's my 625 go? Or 62.5? I cross multiply and divide, what do I get? 390.625 square inches. Very good. Now, rather than going through the trouble of developing this next one, I'm going to throw it out there and see if you guys can figure it out. I'm guessing you will. You know you will. Sure, Josh. You can feel the love. So looking at these figures, my ratio of lengths is what? 1 to 2. It's 10 to 20, which reduces to a 1 to 2 ratio. Now I'm not looking at areas anymore. I have volumes. I heard somebody whispered over there. What do you have to do? Cube it. So 1 cubed is 1. What's 2 cubed? 8. Very good. So the ratio of volumes is 1 to 8. So to find the new volume, 8 times 820 divided by 1, 6,560 inches cubed. What do you think? The tough part with these is not doing the ratios. The tough part is figuring out whether I'm dealing with an area or if I'm dealing with a volume. Because just because it's 3 dimensions does not mean I'm dealing with cubing the ratio. For example, so this one is 12 units high. This one is 18 units high. This one has a surface area of 480 square inches. I want to find the surface area of this one. Oh, we're going to start out with the ratio of lengths again, which is 12 to 18, which will reduce by 6 to give me a 2 to 3 ratio. Am I dealing here with a ratio of areas now or a ratio of volumes? Surface area is going to be an area. It's units squared. So ratio of areas, I'm going to take that ratio of lengths 2/3. I'm going to square it. So it's going to be 4/9. So the 48 goes on top. 9 times 48 divided by 4 is 108 square inches here. Here's one maybe a little bit more interesting for you. Let's go to the discharge pipe. Discharges 600 gallons per minute. What diameter? Let's see, I should put in here a 6-inch discharge pipe, sorry. So a 6-inch discharge pipe discharges 600 gallons per minute. What diameter pipe would be needed to double the discharge volume? Now this one has volume right in the problem, so that means we must be dealing with a volume, right? Say no. No, because we're not dealing with a volume. The diameter of the pipe only changes a length if you're dealing with a diameter, or it also changes the cross-sectional area of that circle. Increasing the diameter changes the area of that circle. But it does not change a length. The length here is a flow rate. We're assuming that the actual flow rate, the speed of the fluid coming through that pipe does not change because we're not altering that at all. So we are only changing 2 dimensions. So all we're changing is an area. So we're doubling the area of the pipe to double the discharge. So we have a ratio of areas that has to be a 1 to 2. So our ratio of lengths has to be what? We're going backwards. So instead of squaring the ratio of lengths, we've got to square root the ratio of areas. What's the square root of 1? 1. What's the square root of 2? 1.414, right? So what we have to do here, there's two ways we can approach this, by the way. I'll show you the other way in just a second. 6 is the smaller one over equals 1 over 1.414. We cross multiply and divide. So 6 times 1.414. Now I'm going to do this 6 times the square root of 2 to make it more exact, so I'm not rounding it. So 8.485 inches. There is a second way we could have done this. We could have done that 6 squared over x squared equals 1 over 2. And then we could have cross multiplied 6 squared, which is 36, right? Times 2 divided by 1. So 6 squared times 2 divided by 1 gives us 72. But what do we have to do with that? That's x squared, so we have to square root it, right? Which gives us 8.485. So either way, our new discharge pipe has to be about 8.5 inches in diameter.
Why didn't you do a 2 over 1? It's a double.
I could have done 2 over 1, and then the 6 would have to be on bottom. Yeah, this is the ratio of areas. You've got to double the area. So you got to go from 1 unit of area up to 2 units of area.
Why wouldn't it be 6 over 1 equals 2 over 1?
Because we don't know what the other dimension is yet. We've got to have a missing number. Okay, so what I've got, the worksheet I gave you on Thursday, where we did 1 through 6 on top, finding the missing dimensions. On bottom, 7 through 16 deals with ratios that involve possibly areas and volumes. So you've got to figure out which ratio is being used. So I'll give you the last 14 minutes here or so to get started on that worksheet.